Yes, so at eBay, I lead the structured data research organization, which consists of two teams, one in Israel and one in the United States. And what does the structured data organization in charge of? So as the name implies, it's all about taking a pretty noisy, unstructured, free text type of data and putting more structure and knowledge into it so that it can ultimately be served to the users through search and recommendation in a more effective way. And through this talk, I will try to take you through some of the challenges that we face in this big scope of structuring the data or adding knowledge to the data. But before that, a little bit about our approach in my team for applied research. We have basically two types of projects. The first type is explorative projects, which is a more independent kind of project. We take a problem that has been less studied and try to tackle it. We do collect these problems sometimes from ideas from our partners, but oftentimes also from our product managers. And also we work with the engineers to try and define an engineering scope. So it's an applied research scope. We usually don't just tackle the problems that we think about without any connection to the product or the engineering. But in this exploration scope, projects may fail. We tend to collaborate more with the academy to try and collect ideas, explore ideas, work with students, summer interns, and so on. Some of these projects, when successful, move into the integration phase, where we work then closely as part of Scrum teams with the engineering and quality of engineering teams in order to bring the models that have proven effective to production and build them with more scale. So these are basically the two types of projects that we have in my team. And I will mostly focus on more mature projects in this talk that are already in the integration phase. So to establish a little bit of basic understanding of the e-commerce domain, I'll start with a few definitions. So first of all, the concept of the item versus the concept of the product, which is a little bit confusing, at least it was to me when I started working in the e-commerce world. So a product is a catalog entity offered for sale. It can be, for example, an iPhone 7 or the FIFA 2018 game for a PlayStation 4. And it has all kind of characteristics and text. An item or a listing, in contrast, is a specific instance offered for sale by a specific seller. So it has a specific price, a specific shipping location, shipping speed, return policy, and so on that are very specific to this particular offering. It can also have, by the way, a condition. It can be new, it can be old, very good, old, fairly good, and so on. So it's kind of tricky to differentiate between the two. Sometimes, when we tackle a problem, we need to define to ourselves, are we solving it for a product or solving it for an item or a listing? So throughout this talk, please remember this distinction between products and items in the e-commerce world. Categories, so those are maybe more intuitive. We have a category tree at eBay and in e-commerce in general. It can vary from one e-commerce provider to another, but essentially it's a category hierarchy starting from 9 verticals. I listed them. Those are the more general type of categories, then down to about 30-something meta-categories, the next level, a few hundreds of L2 categories, and at the end, the leaves, we have tens of thousands of actual specific categories. For example, a juicer can be a category, or men's sporting shoes can be a leaf category. So those are very specific, and again, we're talking about tens of thousands. And last but not least, the aspects or the attributes, those are more structured components that are very basic in e-commerce, and they describe the e-commerce entities, both the product and the items. Some of them are more generic and span almost all the categories, like brand or model or even size or color, that are pretty common. And some are very specific to more specific type of categories, such as zoom for cameras, memory for some electronic products, and for fashion, some style aspects that are very specific to these, and so on and so forth. So these are the basic concepts. Now a little bit about the challenges that we're tackling and a little bit about the solutions that we use. So first of all, categorization. This is one of the most early problems that we need to tackle because we need to assign an item. Here we're talking about the categorization of an item or a listing to a category. And the earlier we do it in the process, the better, because once we establish the category, we know what kind of aspects, for example, to ask from the seller. We know how to do the matching better, and I'll talk about matching momentarily, and so on and so forth. So our approach here is twofold. First of all, we use a recommendation approach because we want to zoom in and help the seller ultimately focus on the category, on the right category. And again, there are a lot of live categories, so we want to kind of make a few top K recommendations that the seller can choose from. Right now, we focus actually only on live category recommendation, but one of the interesting challenges ahead is to also recommend higher level categories based on fewer data, because sometimes we want to make these recommendations very early in the process when we only have a few keywords or a few aspects. Sometimes those are free text, sometimes those are more structured with name-value pairs, but we want to be able to do this very early in the process. But anyway, after the recommendation, we also apply a validation approach, generally speaking, using a binary classifier, because we want to make sure that no mistake has been made, and we want to actually discover the miscategorization cases early in the process. And we found out that despite being able to use the recommendation also to give a score to the ultimate choice made by the seller, applying on top another classification scheme allows us to reach a better accuracy in terms of discovering early the miscategorization cases. So this is about categories. Aspect extraction, a very fundamental problem in the e-commerce domain. We get a free text. Here specifically, I focus on the item title, and we want to be able to put as much structure to it in terms of the aspects. So usually item titles are not phrased as natural language phrases, but actually they are consisting of mostly values and sometimes names of aspects with a few functional words. And we want to be able to identify as many aspects in this free text as possible. One approach to this, we use actually an assembly of approach here, but one interesting approach, which is probably the most common approach also in the literature, is named entity recognition, where we actually define a set of aspect names, which are the entities that we are set to discover within the titles. And then we treat it as a named entity recognition classic NLP problem. We started with a CRF approach. We now developed a deep learning approach, and we are having a paper in the upcoming EMNLP paper about this approach. So there we will share more details. But essentially, the interesting thing is that we found out that named entity recognition does not generalize for all the categories. It's a very specific thing. We need to define it for the L2 category level, which we have hundreds of which poses some scalability challenges in production, but ultimately we couldn't reach the best performance without actually building a specialized model for the L2 category. So for example, cameras are L2 categories, and for cameras we defined a set of about 20 aspects that are most popular for this category, and these are the named entities that we are set out to pursue. And the advantage of this approach is that even if we see a value that we haven't seen before, the named entity recognition model can generalize and discover that, hey, this is a brand based on similar brands that it has seen in the past, and so on and so forth. Item product matching, again, one of the most fundamental problems we deal with. We have the items, we have the listings, now we need to match them to the products in the catalog. Essentially, there are 3 different approaches that we use, each of them in different level of maturity. The first is extreme classification. So we treat it as a classification problem where each product is a class, but remember, we have tons of products in the system. So we have tons of classes here. We need to use state-of-the-art extreme classification approaches, which is classification approaches that can deal with high number of classes. This is one approach. The second approach, refer to it as an information retrieval problem, where the item is actually the query, but a more complex kind of query with sometimes free text, sometimes name-value pairs, sometimes a combination of both. And the index of documents is actually the catalog. Each product is a document, and now we apply a classic information retrieval approach, generally consisting of two phases at least. One of them fetches the top K candidates, and the other applies a more heavy machine learning in order to actually bring the top candidates to the top. And here sometimes we need the top K candidates when we want to make a recommendation of products, but sometimes, since some of the sellers, they do not really interact with the system, they just upload to us a batch of or large number of items together, we actually need to have a very good performance for the top one match, which is a pretty hard measure. So this is the second approach. The third approach I will not delve into deeply because it's the least interesting, arguably, but it also works, a more rule-based heuristic approach, because ultimately, it's very easy to filter the number of candidates in many cases. Once you know the category and you know the brand, you already drill down to a pretty narrow set of products, and then sometimes using identifiers such as GTINs or the brand plus the MPN, which is the manufacturer part number, you can already narrow down without any machine learning the matching problem, and then you are only narrowing down to a kind of, again, binary classification approach when you set to know your confidence. And if your confidence is high enough, you don't need to apply any of the information retrieval or extreme classification approaches. Product deduplication is kind of the step brother of item product matching, but it's an offline process, while matching is an online process where we get a listing and we immediately want to recommend or assert the product in the catalog. Deduplication is an offline process that runs periodically to optimize the catalog and remove duplicates, because each catalog of that scale and that size has tons of duplicates. And here we take advantage of the fact that the process can be run offline. We take advantage of the fact that the products are more mature at this phase, sometimes consisting of already dozens of items that were uploaded by different sellers. So we have better information to deal with that can help us differentiate. But still, it's sometimes a very challenging problem. I gave here some ID why. For example, in cameras, you have a different name for the same product in Europe, in the US, and you still want to know that it's the same product. And if you have two different products in your catalog, then it creates more mess for the users ultimately. So a very difficult problem, but showing better performance than matching, and ultimately used in parallel to the matching in order to create the optimized matching of items to products in our own catalog. I'll actually skip some of the other things we deal with, such as image quality, asserting which images are best quality to use, title quality, asserting which titles are of best qualities to use for products. And sometimes we do not only select the titles, but we actually generate brand new titles because none of the titles is good enough. And I'll just quickly jump into the more exploratory problem I wanted to mention, which is product descriptions. So I mentioned before we have the titles, but the titles typically do not provide all the information the buyer wants to know. So the descriptions actually has a lot of importance in the decision-making process made by the buyer. But that said, some of the descriptions are missing, some of them are not of high quality. So our approach here is to actually use reviews, because reviews are quite abundant in e-commerce, in order to generate automatically description, or to extract at least automatically those descriptions. And it's an interesting problem because we kind of transfer from a subjective language in the reviews into a more factual, objective language as expected in descriptions. But apparently, there are sentences in the reviews that are more factual, more dry, more suitable for description, And we use a pretty interesting approach to extract, identify those sentences, remove redundancies, order them correctly, and ultimately try and generate a description that comes from the users rather than from the seller, which is a pretty interesting problem. And again, I hope we'll be able to publish something more elaborated about that in the near future. So I'll stop here. I hope I gave you a good taste of the kind of challenges we tackle with and the solutions we try to apply. And this is it. Thanks a lot.
Questions over there?
Hi, I have one question. So this is regarding item to product mapping. You said that one of the methods is using IR search, right? How do you form item as a query? Can you elaborate on that, please?
Yeah, and did you also ask about the metrics, or did I miss here the metrics that we use?
Just how do you formulate an item as a query?
Yeah, so as I said before, the item may consist of a free text part and the name value part. And we actually do it in two ways. We have a complete free text representation where we try to take all the information and represent it as a free text. This would be the more classic type of a query. But we also have kind of an advanced query representation where we only have name value pairs, both the ones we extract from the titles and the one that were explicitly provided. And here we use kind of an advanced search approach where we have already names for each value in the query so we can match it better against the document. And we actually do two separate searches in case we have these two types of information.
My primary question is around bootstrapping it. So when you come up with a new item, so do you start with some anchor product and then start finding the nearest products which can map to?
It depends on the actual approach, but in the information retrieval approach, for example, there is no anchor product. We actually filter most of the candidates using a first phase retrieval, and then we use a more heavy machine learning with a lot of features to bring up the best candidate.
Okay, thanks.
Yeah.
Okay, so one question from here. So the thing is, you mentioned that Ido?
Yeah. Oh, okay.
Yeah. Okay. So
sorry, the light is there.
Yeah, I understand. So given a product, you want to match it to the taxonomy. You want to place it in the exact taxonomy of product categorization, right? And you mentioned that extreme classification is one thing that you are using because the number of classes is huge. So in that extreme classification, are you looking at flat classification or any hierarchical extreme classification method that you are looking at?
So, yes, since we're talking, distinguish between the categorization problem, which is extreme but not that extreme, we're talking about tens of thousands, to the matching where we're talking about millions and tens of millions of products to the very least. But here we have no hierarchy, so it's a flat extreme classification problem.
Okay, I see. Thank you.
Hello. Yes, I'm from VIP Shop, e-commerce company. And I think we do a lot of same stuff for the challengers. One question is that for example, for the aspect extraction, so basically to use CIF or any other deep learning model, we need a huge amount of labeled data. So I'm not sure how do you collect this labeled data. Is it, if it's labeled by a human, what's the human scale?
Yeah, so we actually do a combination. The cleanest data is manually labeled data, which is the best to work with. But, unfortunately for the different models, like I mentioned, we have a per L2 category model. It's not scalable enough. So we do use a noisier data that comes from our seller, who provide, in some cases, they provide both titles and explicit aspects. And this allows us to also label the titles according to the aspects they provided. We try to select sellers with high reliability of data so that it's cleaner, but it's still much noisier than the manually labeled type of data.
Okay, cool. Thank you.
Yeah.
Hello. How did you measure the performance of product duplication algorithm? Did you prepare any ground truth data for this task?
Can you repeat? I missed the beginning of your question.
How did you measure the performance of product duplication algorithm.
How do you measure the performance of product deduplication?
Okay, yeah. So the measurement is actually pretty simple. It's essentially precision and recall. You know, we require a certain level of deduplication in the system, and for that measure of deduplication, we measure our precision. The trickier part is how to actually sample the products, because if you sample them at complete randomness, you assume that all products are of equal importance, and this is not the case. In some areas, a duplicate is not as bad as in other areas, so we actually do a weighted sampling, which gives better weight to products that are surfaced more prominently in the UI, and this is also calculated based on the items associated with the product. So this is actually the most complicated part, how to do the sampling. Then once we have the sampling, it's actually a pretty simple precision and recall.
Okay, last question.
Hey, Ido, I wonder, how do you guys enable user exploration?
Again, sorry?
How do you guys enable user exploration?
User exploration.
User exploration?
Yeah.
What do you mean by user exploration?
So basically, encourage users to shop more diversified items.
So this is actually out of scope for my team, luckily maybe.
Sure.
So we're not dealing. This is not part of the challenges that we deal with.
Right.
I can, maybe we can talk offline. I can share my thoughts
good.
about it, but it's not something that is actually part of the challenges we deal with.
Okay, let's thank our speaker.
Thanks.